Okay, so I ran out of time. Give me just a second to get this all back up and going. Okay, there we go. Um, so I think we were saying that based on this information, we did T equals KP because T and P vary inversely. They gave me 25 people working for 300 hours, can complete the job. Find the work time per person if the company hires 30 people. So we have a constant variation of 7,500. So that is our constant of variation. So 7,500 is the number that's going to be consistent. We divide that by P. That's our equation. Now this equation will be able to find P if we know T, or find T if we know P. It says find the work time. So we're going to be finding T. If the company hires 30 people. So 7,500 divided by 30, that'll go into that. 7 divided by 3, that is going to be 2. Is that right? 7, I don't know. I don't have my calculator handy. Hold on. Okay, I just want to make sure my math is right. So 7,500 divided by 30 equals, oh no, I did that wrong. That is 200. I knew that was too small. It's 250. So, oh yeah, 3 would go into 75 25 times with that 0 left over. That 0 and that 0 are gone. 750 divided by 3 is 250. Okay. That's not really all that all that you have to know. So I want to go over to the Springboard book. Here is where they do talk about inverse variation. They do the same thing that we said. K is the constant of variation. So that's still the same. They ask you to graph it. You won't have to do that. They give you some problems. Here's what I wanted to talk to you about. We're going to have to do some problems where we have what's called a combined variation, where they might be 2 unknowns that might vary directly and inversely. Okay, so here's an example right here. Combined variation occurs when variation varies directly with one variable and inversely with another. So they will give you the information when you read the question. Here's another one. Joint variation is another form. And this means that we've got 2 different things, X and Z right there, are both varying directly with Y. Now, how do I know that? Because they're being multiplied times K. So over here, X is varying directly, Z is varying inversely. X is varying directly to Y, Z is varying inversely to Y. Same kind of thing is going to happen though. We're going to read a problem, we're going to set up the equation, and then we will plug in numbers and work the problem. Okay, so let me see if we have an example to work. These were actually part of the homework, but that's okay. I'm going to go ahead and do these and I'll just change your homework. So, for goodness sakes, I need to do this. Hold on real quick. Okay, so here we are. It says Y varies directly as X. Okay, so just that part, Y varies directly as X. Okay, and inversely as Z. So that means Z has to go on the bottom. They give us X is 3. They give us Y is 9. They give us, we don't know k, they give us x is 3, and they give us z is 4. Okay, so they're going to give us these numbers, and now we got to get k by itself because we can't answer the question here until we find k. Here we must know k in order to find anything else. So we've got 9 is equal to k times 3 divided by 4. Get rid of the 4. Multiply both sides by 4. We get 36 is equal to 3k. Divide both sides by 3. 36 divided by 3 is 12. So that means my constant of variation is 12. So when I go back over here, I can write my equation, y equals 12 times x divided by z. Okay, there's the directly and inversely. And now they give me x and z and want me to calculate y. So y is equal to 12 times x divided by z, which is 2. 12 times 4 is 48. 48 divided by 2 is 24. Okay, word problem situation, but I promise you it's going to be the same thing. 205 milliliters of gas have this kind of pressure and a temperature of kelvins. What is the volume? Oh, I guarantee they have us somewhere over here. They've given us a relationship. I can't do it because they didn't give me the relationship, but let's see if we can go back and see what the relationship is. So here's where it talked about it up here. It says Boyle's law is an inverse variation as long as the temperature is a constant. However, if both the pressure and the temperature vary, then the relationship between the volume, pressure, and temperature and gas can be represented by a combined variation. This relationship is referred to. So it says the volume of gas in a closed container varies directly. So volume varies directly with the temperature and inversely with the pressure. So based on what this is telling us, here is the relationship. Volume varies directly with the temperature and inversely with the pressure. So V equals K times T over P. This is, though, the sentence that you need. This is the sentence that the part of the sentence that you need, that right there. If you can't read that sentence, the volume of a gas in a closed container varies directly with the temperature of the gas and inversely with the pressure of the gas. If you can't read that and get that, then you need to come see me so we can talk and do some extra examples. That is what we're going to start with. V equals K over T divided by P. Varies directly. These two vary directly. These two vary directly. These two vary inversely. Okay, so we take that and we go over here to this next page, and we remember that the problem was volume varies directly with the temperature and inversely with the pressure. Okay, so here's the given information. 205 milliliters of gas, that's the volume, have a pressure right there. So they give us 205 equals K times, with the temperature 451 divided by 30.8. So we've got to find K. That's where we start. We have to find K first. So 205, we're going to start by multiplying both sides by 30.8. Multiply by 30.8. 30.8 times 205. That equals 6,314 equals 451K. Divide both sides by 451. Okay, divide by 451. And that calculates out to be K equals 14.